We've got here the number of CDs sold in these different years of Michael Jackson's music. Starting off, we want to go ahead and make a scatter plot of those purchases with year 1990 as year 0. So if 1990 is year 0, first we need to set these years to the proper numbers. So if 1990 is 0, then 1998 is year 8, 2000 is 10, we've got 12, and 19, and 20. And we want to go ahead and make a scatter plot of this. So let's go ahead and go to our calculator, and we're going to create a spreadsheet. We'll go ahead and label. We'll just use X and Y. So label your columns as X and Y. And then down here, we're going to go ahead and enter our years. So we've got 8 and 10, 12, 19, and 20. And then in our Y column, we've got 100,000, 150,000, 300,000, 1 million, and 5 million. Okay, so we've got our data in there. We want to make a scatter plot. So we're going to go and create a graph. So add a graph. And to do a scatter plot, we're going to go to Menu, and then Graph Entry /Edit, and add a scatter plot. And we've labeled our columns in the spreadsheet as X and Y. So our calculator here is asking for what list to use as X, and since we labeled our column as X, that's all we have. And then for Y, same thing for that. Okay, and we hit Enter, and you'll notice we don't actually see anything here. Because it's outside the window, of course, right? We've got up to 100,000. And so to set our window so that it will fit our data, we go to Menu, and then Window /Zoom, and then there's this nice option here, Zoom Fit or even Zoom Data. Either one of those should fit the window to your data. Okay, so now we've got our points, all right? And so you can go ahead and sketch that down, but that's kind of the idea of getting your scatter plot. Now, using the calculator to find the exponential regression function that best fits the data, okay, we need to go into our spreadsheet, and we're going to do a regression. So we're going to go to Menu and Statistics, and then Stat Calculations. And now we've got regression options, and this tells us to do the exponential regression. So we're going to go ahead and go to the exponential regression, which is right here. And it asks us for our X list and our Y list. So our X list, if we click to the right, we can open our list, okay, and select X, and then come down to our Y list and click over and select the Y list, okay, our X's and our Y's. Click OK. And it gives here our equation. We've got a times b to the x, and let me go and write this in here. So our function is a times b to the x, but it tells us a and b. All right. So I'm going to be use those numbers in this function. So I've got 9,818.14. And of course, there's more decimals down there, but I'm just going to go ahead and leave it rounded to 2 decimal places. And then times b, okay, it was about 1.323. I'll go ahead and round that to 2, and then to the x. So there's our exponential regression function for this data. And we would like to know if it's a good fit. And so looking in our calculator, there's this nice handy dandy r and r squared, and r is really all you need for this. Okay, r. And if r is close to 1 or close to -1, then it's a good fit. Okay, if r squared is close to 1, then it's a good fit. And that's the correlation coefficient. Okay, and it tells us how good our model is at fitting the data. So 0.95, that's pretty dang close to 1. And so we'll say, yes, this is a good fit. Yes, this is a good fit because R is close to 1. All right, so now it says, according to this curve, how many CDs sold in 2012? So now all we need to do is use 2012 in this function that we have, okay, with our A and our B. So notice that our actual data, we know that our actual data told us that certain values, and our data actually only goes up to 2010. So we're asking for like two years after this. Let's go and plug it in and see what happens. This would be f of 22, because 2012 is 22 years after 1990, which was our year 0. We get 9,818.14 times 1.3232 raised to the 22. Let's go ahead and plug this into our calculator. 9818.14 times 1.3232 raised to the 22. Go ahead and enter. Okay, and we've got this number here. You'll notice this little E6. This tells us actually this means times 10 to the 6. Or in other words, move the decimal to the right 6 places. And if you want, you can just click up in the calculator to highlight it, and then hit enter, and it'll actually show you that that full number. Okay. And because we're talking about a number of CDs here, we'd actually probably want to round this to the nearest whole number. Okay, so that would be, let's see, we've got 4,653,611 if we round to the nearest whole number. Okay. Now notice, this is important to realize that this is saying that 2 years later it actually sold less than this 5 million, just because this model is not a perfect model. Also, we did a little bit of rounding, okay? But we just found the best fit, the best exponential function to fit this data. It doesn't mean that this data is actually exponential. And that brings us to part D. Do you think this curve will be accurate 30 years from now? Well, 30 years from now, if you think about what we know about exponential functions, they grow pretty dang fast. And if we plug in, a number 30 years from now, well, 30 years from now, it's the year 2020, and 30 years from now is 2050, which would be times equal to 60. Notice that if we plug in our function, but change that exponent to... oops, that's not what I wanted. If we copy this function, but change that exponent to 60, this number is huge. This is the thousands place, the 4, and this is the millions place, and this is the billions place. And this is saying this would be 194 billion sales of CDs. And that's just not super realistic, right? Because that would be saying, everyone on Earth is buying lots of Michael Jackson CDs. And so this model is probably not going to be accurate unless something amazing happens. And people go crazy about Michael Jackson in an unhealthy way in 30 years.